Okay, good morning, class. So at this point, we're looking at Euclidean geometry. We are on the second theorem, correct? So now we're looking at theorem 2. Okay, I'm going to pause the video at this point. You'll find the link to the proof, to all the proofs for grade 10 and 11 Euclidean geometry in the description box below. Okay. Alright, so at this point, as we're going to use this theorem, we know that angle at center, we've got a circle. We know that the angle at the center is twice the angle at circumference. Okay. So if this angle is 50, then this one would be 100. If this angle is 50, then this angle is 25, and so on and so forth. Okay. Some other thing that you must note at this point is that you see that angle at center. Okay. As long as it's the same arc that's obtaining the angle at circumference, it will be half. Can you see that? So if this is 20, this will be 10. Can you see that before? You all agree with that? You all okay? Otherwise, if this is 20, and this angle here is also 10. Can you see angle at center? Just twice angle at circumference. Can you see that, people? So that point can move wherever, as long as it's touching the circumference, it will be 10 degrees, provided that it's 20. Do you guys understand? So let's look at the application of this quickly. This is example 1, and example 1 is on page. Example 1. Alright. So here we are told that circle center O. Circle center O. So for us to use that theorem, we must be told that you have the center, where you have a diameter. You guys understand? So circle center O with point A and A, B, and C on the circumference of the circle. Angle A is 43 degrees. So what I do is I put 43 in there. 43 degrees. Calculate the size of angle O1. So how do you think we're going to calculate the size of angle O1? It's going to be angle at center is 2 times the angle at circumference. Can you see that, people? Angle at center is 2 times the angle at circumference. So what is angle O1 equal to? 2 times 43, which is 86 degrees. You didn't have to show your calculation. You could have gone straight and say it's 46. Okay. Pull this down here. And why is that 46? Because 86. Why? Angle at center equals 2 times the angle at circumference. Angle at center is twice the angle at circumference. Okay. Any confusion there? Huh? No. Then they ask you to calculate angle B1. Angle B1. How are we going to calculate angle B1? Who can tell us? B1 is also equal to which angle? C1. Why? So angle B1 is also equal to C1. Why? Angles opposite equal sides. And what makes the sides equal is because of the radius. You must say radius. No? Otherwise, you must first say that OC is equal to OB, radii, and then you can say this. Otherwise, you can say it in one. As this is now. Okay? So have I calculated the B1? No. So what do I do now? C1 plus angle B1 plus 86 is equal to 180. Reason? Sum of triangles. And it's triangle COB. You can say interior angle of triangle, or three angles of a triangle, whatever you normally say. Okay? Provided the reason is acceptable. So what's going to happen now, people? We have two variables here, but they're the same. So I can write it as 2 angle B1. Why do you think I'm not going to go with angle C1 and rather B1? Nope. Because of the question. The question says B1. That's why I'm going with B1. Okay, so what I do is I take 86 over the equal sign. So 180 minus 86 will give us 94. Not so? So now what do I do with 94? Divided by 2, which gives you the answer. Sorry? 47 degrees. People, you guys understand? Any confusion? Any confusion, people? No. Right, let's go to example 2. And example 2 is on page 280. Example 2 on page 282. Okay. So we are told circles intercept with points A, B, and C on the circumference of the circle. So as you can see here, A, B, and C is touching the circle. So it's on the circumference of the circle. Can you see that? Then we are told that AO is parallel to BC. If AO is parallel to BC, what do we know? Lines are parallel, what can we conclude? Alternate angles are equal, yes? Cointerior angles supplementary, yes? Corresponding angles are equal. What theorem are we going to use here? Which one of the three? Alternate. Can you see that Z being formed there? So if you look at the alternate angles, then this angle is equal to that angle, not so? Go the other way around, this angle is equal to that angle there. You guys understand? Right. Then we are told that angle A is 20 degrees. Angle A is 20. Prove that angle B is equal to twice angle A. So what's the size of angle A? 20. If I can prove that B is 40, I've done the job. Not so? Now also in pursuit of calculating or proving that angle A, double A is equal to angle B. In pursuit of calculating that, I can't use that fact. Okay? I can't use that fact. I must end off with that statement. You guys understand? I must end off with that statement. So, where do we start? Which other angle is equal to 20? We say that angle C is 20. Why is angle C 20? So alternate angles with CB being parallel to AO. You see the alternate angles here. Now what? Which other angle can we work out now? Angle O. How are you going to calculate angle O? Huh? Angle at center is twice the angle at circumference. Can you see that, people? You see this arc AB is subtending this angle O and it's subtending angle C. So that angle is going to be 40 degrees. Will you guys understand? So angle O is equal to 40 degrees. Why? Angle at center is equal to 2 times the angle at circumference. You guys okay with that? 40 degrees. Ever answered the question?